Good morning, dear students. Today we will solve February March. Today we will solve February March 2026 AS level. So we will start from question number 1. What is the value of ratio 1 kilometer divided by 1 nanometer? Okay. 1 kilometer means 1 into 10 to the power 3 divided by 1 into 10 to the power minus micro nano pico nano 10 to the minus 9 equals to 1 into 10 to the power 9. If 9 goes up, it will be 12. 10 to the power plus 12. 10 to the power plus 12. So 10 to the power plus 12, answer is D. 1B. Question number 2. What could reduce systematic error? Average systematic error. Systematic error, actually error occurs due to the system, not by us actually. So we need to replace the system. What could reduce the averaging a large number of measurement? No. For repeating and averaging, it can reduce the uh, random error, not systematic error. Carefully calibration the measuring instrument. Careful calibration of measuring instrument. Yeah. If calibration is wrong, then there will be a systematic error. So if calibration, we will need to calibrate it. I think this is the answer. Let's read the other. Reducing the sample size, no, it will not affect. Repeating measurement, it is again for the random error. So question number 2, I think the answer is B. Yes, the answer is B. Um, Student measures the current and potential difference for a resistance in a circuit. Current is given, potential difference is given. The measurement used to calculate the resistance. What is the percentage uncertainty calculated for the resistance? We know R equals to V by I. Okay, so the percentage uncertainty we can calculate the percentage uncertainty of B plus the percentage uncertainty of I will give the answer. So how to calculate the percentage uncertainty? We know for percentage uncertainty, the equation is del x by x into 100. So we can easily put the values here. For B, voltage 1 by 0.1 divided by 500 plus. For current, I can write as well 0.01 divided by 50 whole bracket into 100, and the answer will come now. It's here. If you use your calculator, 0.04%. 0.04%, the answer is D. Question number 4. Graphs can be used to represent the motion of an object. Which relationship between the quantity of motion and property of the graph of a graph is correct? Okay. Acceleration is the area of velocity time graph. No. Area of velocity time graph is distance. It's wrong. Acceleration is the gradient of velocity time graph. Yes, it is correct. Displacement is the gradient of velocity time graph. No. Velocity is the area under the graph of displacement. That is not as well. So question number 4, answer is B. Question number 5. The water surface in a deep well is 78.0 meter below the top of the well. A person at the top of the well drops a heavy stone down the well. Air resistance negligible. Speed of the speed of the sound is 330 meter per second. What is the time interval between the person dropping the stone and hearing it hitting the water? Okay, let's try to draw. Suppose it is the well site, and here the height is 78 meter. 78 meter. A stone is dropped from this height, 78 meter. Okay. Then a sound will create here, and that sound again you will listen that sound here. So what is the time interval person dropping the stone and hearing the, so we need to find two time here. Suppose I need to find the time for reaching the stone from here to uh, on the water. So here I can use the equation for the first. We can use s equals to ut plus half at square. Ut is 0, so t equals to root over 2s divided by a equals to root over 2 into distance is 78. Acceleration, c, air resistance is negligible, means we can use here acceleration is 9.81, and we are getting the time. If you calculate this, the time is 3.99 second. Okay, now here the time is 3.99 second later the stone hits the water. Now it's about the listening the sound of water, and it will come it again. So we can use here the speed will of sound in air is that is given 330, and constant speed we can calculate the time. T equals b equals to s by t, or s equals to bt. So t equals to s by b. Distance is again 78 divided by time is 330, and we are getting the answer here 0.24 second. Now if I calculate both, so total time equals to 3.99 plus 0.24 equals to 4.22 second. The answer is 4.22 second. The answer is D. 5 answer D. Okay. And 6. A toy car moves in a straight line. The graph shows the variation with the time and displacement of the car from its initial position. Displacement. So here this is T1 is rest. The student investigate whether the force acting on the car is in equilibrium at 4 different times t1 t2. At which of the time of the forces acting on the car equilibrium. Force equilibrium means resultant force is 0. Okay, t1 time, this is in rest, so resultant force equals to 0. Rf equals to 0. Here for the displacement time graph, this one is constant speed. If speed is constant means also resultant force is 0 here. So equals to 0 here as well. This is again rest. So rest means 0. Again here constant speed, resultant force 0. Oh, okay. Everywhere the resultant force is 0 here. See. So T1, T2, T3, T4, I think everywhere. Throughout the whole journey, the resultant force is 0. So 6 answer A. 7. A car travels anti-clockwise along a horizontal circular road of radius 12 meters shown in the figure. The car takes 4 seconds to move from position P to Q. P to Q. Position P to position Q. Okay, the car takes 4 seconds. 4 seconds. What is the magnitude of average velocity of the car? Average velocity. Average velocity V equals to total displacement divided by total time. Total displacement total displacement divided by time. P to Q. If I need to measure the displacement, I need to know this one. Okay, this one is the displacement, and time is 4 second. Time is 4 second. Now how to calculate this one? Oh, this one is easy now. Actually, if this is s equals to It's a triangle. So it is 12, then it will be also 12. So 12 square plus 12 square equals to 16.8 meter if you calculate this. So 16.8 divided by 4, if you calculate, the answer will come 4.2 meter per second. 4.2, what is the answer? 4.2, any 4.2? Yes, the answer is A. Nice. Question number 7. 7A. 7A. Question number 8. A person is suspended from a rope vertically below a helicopter. Okay, here a person is suspending. The helicopter and the person are stationary above the ground. Which force forms Newton's third law? Pair weight of the person. Weight of the person. Weight means the relation between the person and the earth. If earth is here, the relation between, if this is earth, so earth and the person. So according to Newton's third law, action force and reaction force will both act on the opposite object, the acting. So the man is attracted towards the earth, and then earth is attracted by the man, right? Action and reaction force. The force of the tension force of rope on the person, no. The force of upthrust, no. The gravitational force applied by the person on the earth, yes, I think C is answer here. The gravitational force applied the person on the helicopter, no. So question number 8, we got the answer. The answer is C. Question number 9. Two small moving particle collide. After the collision, the particle move off different direction. Okay. What is essential for the total momentum to be conserved in the collision? Collision. Collision may be elastic or inelastic, but momentum will always remain conserved. That's the point. So no external force act on a system. The two, yes, I think this is the condition of principle of conservation of momentum. What we know, if no external force act on a system, or then the resultant force, if there is no external force act on a system, before collision momentum will be equal to the after collision momentum. So essential conserved means before collision momentum is equal to the after collision momentum. So if no external force act on a system, I think this is supposed to be the answer. Let's check. No kinetic energy is lost, that is for the elastic collision, not conserved. The collision is inelastic, no. The relative speed of that is also for the elastic collision. So 9, we got answer A. It's about 10. For 10, block A of mass, block 1 of mass 3 kg. This one is 3 kg. Frictionless table, a rope of negligible mass attached to the block. The rope passes over the frictionless pulley. Block 2 have a mass of 1 kg. This one is 1 kg. Is suspended from the other end of the rope. The block accelerate. Acceleration of free fall. The block accelerate. Okay. Acceleration of free fall of is g. Actually, the block accelerate, this one is not equal to the acceleration of free fall, not equal to g. Don't be confused. The unit of g is meter per second square, and the tension of the rope, tension acts only on the object, this one. Here this is T, tension. What is the tension of the rope in terms of G? What is tension of the rope? Okay, what is the tension of the rope? Okay, tension will act, tension, actually F, tension is a kind of force, so we know that F equals to ma, tension equals to ma. So here M is, tension is acting on 3 kg mass, so M will be 3 into A, acceleration. I need to find the acceleration first. Acceleration first is, we know that a equals to f by m. F equals to ma. So a equals to f by m. Here a equals to f by m. F F is the force which is acting for the weight here actually. So F equals to mg. F equals to mg means m means 1 kg. Here m is acting 1 kg and g is g divided by m. Acceleration is acting. Acceleration is acting the system on the system means both 3 and 4 kg they are accelerating. So it is a system. So mass is here 3 plus 1 equals to 4. So g divided by 4 is acceleration. We can use this value here. 3 into g divided by 4 equals to 3g by 4. Tension equals to 3g by 4. Is there any, right? 3g by 4 is the answer, I think. 3g by 4. Number 10. It's about number 11. 11. Okay. Um, Mass of an object can be determined by its relationship to other physical quantity. The relationship shown at the figure. Resultant force mass m equals to f by a. Resultant force is directly proportional to acceleration. So mass, the relationship shown. Yeah, I think this is correct. We can calculate mass here. Linear momentum p equals to mb. P equals to mb. Linear momentum divided by velocity. P equals to mv. Velocity p equals to mv. So m equals to p by b. We can tell here. We can tell this one. We can tell this one. Weight of an object divided by acceleration of the object. Okay. Let me clear one thing. Suppose a man of mass 2 kg by an object of mass 2 kg is accelerating 2 meter per second square. Here, can we find mass F equals to by using the equation F equal weight and acceleration. So W acceleration of the object. We know W equals to mg. So this is actually m equals to W by g. G is the gravity is 9.81. But here m equals to F equals to ma. Here F equals to ma. So A equals to F by m, or m equals to f by a. So f by a is not equal to 9.81 always, which means acceleration of the object is not always equal to the 9.81. So we cannot use this equation. I think you are clear. So 11 we are getting only 1 and 2, which is B. Okay, let's do 12. A basket is sliding on a horizontal frictionless surface with a velocity 30 centimeter per second. The mass of the basket is m. Okay, the block of mass 2m fall vertically into the basket. The block and the basket then moves together with the same horizontal velocity b. What is b? I think this one is easy. We can calculate m1 u1 plus m2 u2 equals to the basket and the block. They make one object m1 plus m2 into final velocity. They are asking for the final velocity. M1 m into m into 30 plus c. The object is moving in another direction, from another direction, so there is no component with the motion of this velocity. So we velocity here m2 2m into 0, no component in horizontal direction, so 0 equals to m1. M1 is m plus 2m into b, so b equals to 30 divided by 3 equals to 10 meter per second. I think 10 is here. Yes, I think the answer is 10 meter per second. 12. Number 13. Two children, two children are balanced horizontally in equilibrium on a plank. The plank is uniform with mass 7 kg, length 3 meter. There is a pivot at the midpoint of the plank. Oh, the pivot is at midpoint. So this 7 kg will not create any effect either clockwise or anti-clockwise because it will act on the pivot. Why? This is the center of mass will act at the midpoint. So midpoint we have pivot. So do not think about this 7 kg. Child X has a mass 20 kg. Distance X from the pivot. Child Y has a mass of 15 kg and is distance Y from the pivot. What is the value of ratio X divided by Y? Okay, if I consider the moment 20 into X equals to 15 into Y. So they are asking for X by Y. X by Y equals to 15 divided by 20. 15 divided by 20 is 0.75. 0.75. I think the answer is C. We got the answer 13 answer C. It's about 14. The diagram shows two ways of hanging the same picture. Okay, same picture. In both cases, a string is attached to the same point on the picture and looped symmetrically over a nail in a wall. The forces shown are those that act on the nail. Okay, the weight of the string is negligible. Diagram 1, the string loop is shorter than C2. In which information about the magnitude of forces are correct? R greater than RR. What is R? R is the R is given to diagram 1, diagram 2. In both cases, string attached to similar forces shown on the weight of the string is negligible. Diagram 1 shorter actually here R is the weight. R is the weight because R is balancing. Both weight are equal. Same picture means their weight is equal. So R1 and R2, R1 and R2 they are equal. R1 is equal to R2. R1 is equal to R2. R1 is equal to R2. Okay. Here T1 will be greater. Why T1 will be greater? Because if angle increases, the value of if angle in cos theta will decrease, so T need to be increased. Suppose here R1 balancing T1, here theta is less, here theta is small. R1 equals to 2 T1 if this is theta, T1 to T1 cos theta. If cos theta increases, total value will decrease because cos 90 equals to 0, cos 0 equals to 1, right? So if this value of cos theta decreases, this T1 needs to be increased because R is constant here. So T1 is greater, T2 is less. T1 is greater, T2 is less. The answer is B. The answer is B. 14, answer B. 15. The diagram shows four metal cylinders submerged into the container of water. Which cylinder has the greatest pressure on the top of the surface? Okay, liquid pressure actually depends on liquid pressure. P equals to H rho G. Density constant, gravity constant, the height. I think here the height is the greatest one. Most uh, height is larger. So I think C is the answer. C is the answer. 15. 15 answer C. Acha. Okay. Now 16. Three solid block P, Q, and R shown in the figure. The dimension and the mass of the object given in terms of length x, mass m. Which objects they have the same density? Okay, I need to calculate the densities for all. Rho equals to m by b equals to m is m and b is x cube, right? Because the all sides are x here, x cube. This is for p. Now rho of q, mass is 4m divided by volume is 2x into x equals to 2 by 4 equals to 2. So 2m divided by x cube. They are not matching. And then rho r. Mass divided by volume again. Mass is the m. It's a cylinder. So the equation is pi r square L. Pi into r means here x. R is the radius. So x square into this one is the length actually. This one is length x by L into x by pi. X by pi. So we can cut here pi equals to m divided by x cube. Oh, I got the answer. M by x cube, m by x cube. So p and where's the answer? P and r only. P and r only. This is the answer. 16. 17. Small ball is projected into the air from horizontal ground. The diagram shows the path of the ball. Path of the ball here is given. The ball leaves the ground at a point x with a kinetic energy 8 joule. Here the kinetic energy is 8 joule. A short time later, the ball is at point y. Kinetic energy 3.5 joule. Here the kinetic energy equals to 3.5 joule. Point y is at vertical height 8.8 meter. Okay, 8.8 meter above the ground. Air resistance negligible. What is the mass of the ball? Okay, what I can write here, kinetic energy 8 joule to 3.5 joule means when it is going up, kinetic energy is decreasing. So if kinetic energy decreases, potential energy will increase. So this loss of kinetic energy will convert to potential energy. So what we can write, suppose here initial kinetic energy is 8 minus 3.5. This one is converting to potential energy. This is the loss of kinetic energy equals to potential energy. Equation is mgh. Okay, so m equals to 8 minus 3.5. 8 minus 3.5 divided by 9.81 into height is 8.8. We are getting answer here 0.052 kg. Got the answer 0.052 means the answer is B. Got it? 16. A boat requires a power P to move through still water with a constant velocity. Listen, for constant velocity, we have only one equation for the power. It's P equals to FB. Okay. There is a drag force acting on the boat. What is the velocity of the boat? Drag force F. Constant velocity means actually forward force and backward forces are equal. So here drag force and forward force the same so in place of forward force we can consider this is drag force as well. So B equals to P by F. B equals to P by F. B equals to P by F. Yes, the answer is C. 18, answer C. Then 19. When the speed of an object is increases from 10 meter per second to 20 meter per second, its kinetic energy increases by E. What is the increase in kinetic energy of the object when the speed increases from 70 to 80 meter per second? Okay, okay, okay. I can calculate like that here. Suppose the initial del E, initial del E, half mb square minus half mb square, half m b1 square minus b2 square equals to half m into b1 means 20 square minus 10 square. We got here 150 m. 150 m. Okay, now final, for the final I can write here final del E equals to again half m. Here the value is 70 and 80, so it's 80 square minus 70 square, and the answer came here 750 m. What is the increase in ek of the object? Speed, kinetic energy increases E. So if 150 m is the E, so increases by 750 m divided by 150 m is, I think it is 5. So here we are getting 5e. See, 5e, 19, 5e. 20. Trains supply coal to a power station. The table shows quantity describing the operation of a power station. Power station average output, number of the train, mass, coal. So which expression gives the efficiency? Okay. What do we know about efficiency? Efficiency, the output divided by input. Power station average output P. So it will be P will be here. Input power. So input power is energy into time. Energy into time. So energy, first of all, energy of 1 kg coal is E into energy divided by time. Power is energy divided by time. So energy of 1 kg, and then here m amount of mass and number of train per day is n. This is total energy, and number of second in 1 day is s. So it will be energy divided by time is power. So what we can write finally, ps divided by nme. ps divided by nme. 20, answer A. Okay, 20, answer A. 21. Which description of the object undergoing elastic and plastic deformation are correct? Object undergoing elastic deformation. Elastic deformation means it will come back to its initial position again. Not permanently deformed. Yes, not permanently deformed. Object of plastic deformation, there's a permanent deformation. Permanently deformed. I think the answer is D. Answer is D. 21. Answer D. 22. A force F extend the length L of a uniform wire by extension E. The wire has diameter D. Obey Hooke's law. What is the Young modulus of the material? We know about from the Young modulus E equals to FL divided by AX. Here F is F, L is L, A is pi, extension is diameter D, means pi r square. Pi r square means pi d square divided by 4, because here the diameter is given, into x is extension, but E is here, E. So what we can write here, 4 will go up, 4FL divided by pi d square E. 4FL divided by pi d square E. 22, answer is D. 23. This is a tricky question. C. Try to do it fast without seeing the mark scheme. Um, a 8 Newton weight is attached to the lower end of the spring, which is fixed at the upper end. The weight is initially held at rest at position X and the spring is unstressed. The weight is then released and fall to position Y, which is 4 centimeter below. Okay, which is 4 centimeter, it was initial position. This is 4 centimeter below. The weight oscillate, then eventually comes to rest at position U, which is 2 centimeter below. How much energy is lost in the system? Energy lost. Initially, this one is the initial um, position, and this is the final position. So here, that there is a loss of gravitational potential energy. First of all, I need to find the total gravitational potential energy loss. Total gravitational potential energy loss equals to mgh. So mg is here 8 into total 0.02 equals to 0.16 joule. 0.16 joule. But here some energy is gaining by the spring. That is the uh, elastic potential energy. Elastic potential energy gained by the spring. So elastic potential energy gained by the spring equals to W equals to half Fx. So half into F is 8, extension is 0.02 equals to 0.08 joule. So total loss is 0.16, but the 0.08 joule energy is again stored as a elastic potential energy in the spring. So how much energy is lost from the system? So finally we can calculate the loss. 0.16 minus 0.08 equals to 0.08 joule of energy. 0.08 joule of energy. 23. Answer is B. 24. An electromagnetic wave has a frequency 3.3 into 10 to the 14. Which principal region of the electromagnetic spectrum is in this wave? See, first of all, try to find the wavelength. Lambda equals to C by F. So C is the speed, it is electromagnetic wave. So the speed of light 3 into 10 to the power 8 meter per second, and the frequency is 3.3 into 10 to the power 14. 3.3 into 10 to the power 14. So 3.3 into 10 to the power 14. I think the answer is The answer is 909 nanometer. 909 nanometer. 909 nanometer. So, do you know the wavelength of visible light? For visible light, I think it is 700 nanometer, 400 nanometer to 700 nanometer. This is visible light. So wavelength is longer than visible light. So busy longer than visible light wavelength means frequency is less, which means less frequency than visible light. So this is infrared. We know that radio wave, microwave, infrared, then visible light. So infrared is the choice here. Infrared 24. Answer A. 25. 24A and then 25 is a wave on a stress string causes the particle on the string to vibrate. The diagram shows the part of the string at one instant. P, Q, R. There are 3 points. Particle selected, the string instant. P, Q, R particle of the string. Which statement about the particle of the wave is correct? If it is progressive wave, particle P and Q vibrate at a phase difference 90 degree. P and Q. P and Q. If it is progressive wave here, this is 90 degree. From P to this point, the phase difference is 90 degree. 0, 90, 180, and then this one 270, and then 360 to the total. We know that for the progressive wave, total circle is the 360 degree. So each one is 90 degree. Each one is 90 degree. So here to here, not P to Q. So this is wrong. If it is a stationary wave, particle P and Q vibrate with the phase difference 90 degree. P and Q. If it is a stationary wave, listen one thing very carefully. All the points from node to node, the phase difference is zero because they are all moving in the same direction. So there is no phase difference. But adjacent loop in stationary wave, the condition is same node to node, mean in the same loop the phase difference is zero, but for the adjacent loop they are 180 degree. Suppose Q is moving in this direction and R is moving in this direction, so there is anti-phase. So here Q and R, they are 180 degree, but P to Q, they are 0 degree. This is applicable only for the stationary wave. If it is progressive wave, Q and R with the phase difference 180, no, from here to here the phase difference is 180. If you consider this is 90 and this is 90, phase difference 180, but Q to R phase difference is not 180. If it is a stationary wave, particle Q and R vibrate with the phase difference 180, yes. What am I telling? Adjacent loop, always they are antiphase. That is very important. Question number 26. What describes the displacement of a particle on a wave? Displacement in a specific direction of a particle from equilibrium position. I think this is the answer. I can read the next rest also as well. The distance moved in a specific direction per unit time. There is no relation between time and displacement. The maximum distance equilibrium position. This is amplitude. This is amplitude. Displacement of a particle on a wave. What is the describe the they're asking for the displacement, not for the amplitude. The product of a speed and wave. No. So what is the question number 26? Answer I am getting. The best choice is A. The distance in a specific direction of a particle from the equilibrium position. Okay. Now question number 27. Polarization. Okay. The beam of particle light intensity I naught incident normally on a polarizing filter. The transmission axis of the filter is at an angle 60 degree to the vertical. The transmitted light beam is then incident normally on the second polarizing filter. The transmission axis of the second filter is perpendicular to the vertical shown in the figure. Okay, if this is intensity second, this one here it is IT. The intensity of the light beam that emerges from the second filter is IT. This is IT. and beam vertically, this is I naught. Here, this is I naught. This is I naught. What is the ratio? IT divided by I naught. Okay. If this is I naught, 60 degree from the vertical, here I can find if this is I1 equals to I naught cos square 60 equals to I naught into what is the value of cos square 60? 0.25. I naught into 0.25. Now, this is input for second filter. Here, IT equals to 0.25 I naught cos square. What is the angle here? If this is 60 degree and this is becoming the vertical, means here from 60 and then it is 30, so it will be 30 degree. Cos square 30 degree, cos square 30 degree. So we are getting here the answer 0.1875 I naught. So what is the ratio? IT is the 0.187, means we can write 19 I naught divided by I naught. We can cut the ratio of 0.19. Yes, we are getting the answer 0.19. B is the answer here for 27. 28. A car is driving along a straight road while emitting the sound of constant frequency. Okay. There is a stationary observer at each location X, Y, and Z. So here is the observer, here is the observer, here is the observer. 3%. From X to Y, the car is accelerating uniformly. X to Y acceleration. See, if the car moves at a constant speed, there will be a change of the frequency will increase, and that will be the constant frequency. The frequency will increase, but that will be a constant number. It will not change. But if the car accelerates, coming forward, coming towards X to Y, but it is accelerating, that's the point. The frequency will continuously increase. Okay, so frequency is directly proportional to actually the change in velocity. Velocity increases, frequency will increase. So here the acceleration increase, there is a acceleration, uniform acceleration, speed increases, so frequency will increase till y, and then it's moving from y to z. The car continues at this constant high speed. This constant high speed means, yes, till here the frequency will increase, and that high frequency and will be constant here throughout the y to z. Okay, which observer will hear the highest frequency of the sound, and what is the position of the car when the frequency is heard by the observer at X? No, the frequency will decrease here because it is backside. At Y, between X to Y, at Y between X to Y, at Y between X to Y. No, the car position will not be in X to Y. The car position will be here actually, Y to Z. At Y. See, if it is at Y, between Y to Z, the frequency will start decreasing here. When just after it will pass, the frequency will start decreasing. So in between X, Y and Z, in between Y and Z, the frequency will start decreasing again. That's the point. See, from Y, the person will start hearing the same frequency from Y to Z. Y to Z. At Y, the frequency is suppose maximum, but when it will just pass, the car will pass from Y, the frequency of Y will start to decrease. There, that is the point. At Y, he will hear the at Y, the person Y will hear the frequency. The Z will hear the same frequency when they are at Y. But in the option, it's not like that. At Y, between Y and Z, between Y and Z means the car is here or here. When just Y, the car will pass Y, the frequency or at Y will decrease. So at Z, yes, between Y and Z, yes, between Y and Z. So the answer is D. I think the answer is D. Yes, the answer will be D. Answer will be D. I think it's clear again. Okay. And then question number 29. Each diagram shows the stationary wave on a stressed string. Which diagram is correctly labeled? It is antinode? No. This is node? No. Antinode? Yes. Antinode? Yes. Antinode? Yes. Node? Yes. Node? Yes. Wavelength? No. Wavelength is the complete wave. So it is half wavelength. It's not. Wavelength is this one. So answer is D. I think the answer is D. Answer is D. 29. 30. Two coherent electromagnetic waves are traveling in vacuum. Coherent means same frequency and constant phase difference. The phase, so which means the both wave, the frequency will remain constant, and they have there is a phase difference between them. Constant phase difference. The phase difference will not change. Two coherent electromagnetic travel in the vacuum. The two wave meet at a point. At this point, the two wave have different intensity. Actually, intensity is related to amplitude. There is okay. Which a statement about the wave is not correct. Okay, they have constant phase difference at that point. Yes, that is correct. Correct. They have the same amplitude. Wow, the intensities are different. They are asking here the intensities are different. So how they have the same amplitude at a point? It's not possible. So I think this one is the answer. They have the same frequency. Same. I told you a bit back. Coherent means same frequency, and they travel the same speed. If the frequency is same, time period will be same, um, speed will be same, that are same speed. Yes, coherent source, so they are traveling at the same speed. So 30 answer B. It is not incorrect, it is not correct. 30 answer B. It's 31. Laser light of single frequency is incident normally on a diffraction grating with etho 5 into 10 to the power 5 lines per meter. C, calculate, first of all calculate D here. D equals to 1 by 5 into 10 to the power 5 equals to 2 into 10 to the power minus 6 meter. Okay. Diffraction pattern is found on in the grating as in the distance 3 point. The screen is a distance 33.5 centimeter from the grating. Okay. This is capital D. Capital D. Okay. Grating. The distance between the two first order intensity maxima is 15 centimeter. I need to draw this now. Else it will not be clear for you. Here n equals to 0. Suppose here n equals to 1, and here again n equals to 1, and it's coming from here, so this one and then this one, they are asking, it forms a triangle. See, it forms a triangle, and here the first two order maxima is 15 centimeter, which means this point to this point is 15 centimeters. So here this one is 7.5 centimeters, and this point too. See, the screen is at a distance of 33.5 centimeters from the grating. Here to here, this is 33.5 cm. So now I can calculate theta. Theta. Sine, no sine, no sine, cos, no cos, tan. Yes, I can use tan. Tan theta equals to 7.5 divided by 33.5. So theta equals to, if you calculate this, it will, the theta will be 12.6 degree. Nice. Now what is the wavelength? We know d sine theta equals to n lambda. So lambda equals to d is 2 into 10 to the power minus 6. 2 into 10 to the power minus 6 into sine theta is 12.6 Sine 12 point sine theta actually is not sine theta, means sine 12.6 divided by n is 1, n equals to 1, and the answer is 436 nanometers. 436. Okay, the answer is 437. 437. 31. Answer is 437. Okay, 32. Which graph represent the variation I and current and potential difference of a filament lamp? We know that for the filament lamp is a non-ohmic conductor. When suppose this is voltage, here this is voltage, volt, current, ampere. For the filament lamp, when voltage increases, the resistance of the filament increases as well. So for that, current will increase, but the increasing rate will decrease, which means the graph will be like that. The graph will be like that. For filament lamp, the voltage will increase, but the current will not increase that much. Here, if you consider, okay, oh, there, here, see, current in the in x-axis, voltage will be in the y-axis. So the graph will be on the reverse side, opposite side. Opposite side is this one, so it will be like that. Opposite side is B. Opposite side is B. Filament lamp is a conductor, so both way, plus side or minus side, both way, the characteristics will be same. But here D is, I think this is semiconductor or something like that. It's not appropriate answer. So 32 is B. 33. What is the definition of potential difference? Potential difference B equals to W by Q. Work done per unit charge. You have idea about it. Energy per unit charge. Okay, I'm getting the answer first here. I think this is the answer. Energy transfer per unit time, no. Power dissipated per unit current, P, ET, no. P into I, no. Product of current and resistance. No, that is not the definition. Suppose here product of current and resistance, we know that B equals to IR. This is Ohm's law, right? This is the definition of resistance actually. R equals to B by I. Here current resistance is the voltage per unit. Resistance is the voltage per unit current. But this is not the definition of potential difference. Definition of potential difference is B equals to W by Q. That is important. 34. 34. See, conducting putty is a substance that conducts electricity and can um, mold it into various shape. Okay, a cuboid made from this putty has a length with x, resistance of the square face of the cube is 15. Some more of the putty is molded into a cylinder that has length L by 2. The resistance between the cylinder faces is also 15. What is the radius of the cylinder? Resistances are equal. Suppose if I draw it here, suppose this is that cylinder, it is that cylinder. So here area, how to calculate the area of the cylinder? Pi r square. Area equals to pi r square. Here resistance R equals to rho L by A. Here L is a small capital letter L, so it will be capital letter L. Here also R equals to rho, same. L is L by 2. Area is pi r square. Area is pi. R is given. X. What is x? Okay, pi r square. Pi r square. I need to calculate the radius so I can make subject. Both cases, what can I do? Their resistance is 15, so which means they are equal. They are equal means rho into L divided by 2 into pi r square equals to, divided by 2 I'm writing here at the bottom. The same thing, resistance equal. So rho L divided by A. I can cut rho L L Here is area is x actually. For this area, this side, we can area means side x, which is x square. So r square equals to r square r square equals to, if I place it, x square divided by 2 pi. R square equals to x square divided by 2 pi. Okay, r square x square. Okay, so r equals to x square, so it will be x root over 2 pi, x divided by root over 2 pi. R equal x divided by root over 2 pi. The answer is B. The answer is B. 34 done. 35. Each of Kashyap's law is linked to the conservation of physical quantity. Okay, physical quantity, we know about it. Kashyap's first law means conservation of charge, right? And Kashyap's second law is conservation of energy. That's it. First law, conservation of charge. Second law, conservation of energy. The answer is C. 35. 35. Answer is C. 36. Eight identical resistors are connected, shown in the figure. Emitter A1 1.5 ampere, A1 1.50 ampere. What is the reading of A2? Okay. See, one resistance is 1.5, two resistance. So the resistance becomes double at upper side. So current will be half. So what will be current here? The current will be 1.50 divided by 2 is 0.75 ampere. Current will pass here. What is the total current of the circuit? Add these two. This one will be equals to 2.25 ampere is the current. Now see here, 1 2 3 4 5 5 resistor, 5 resistor, 5 resistor. So 2.25 divided by 5, I am getting 0.45 ampere current. Okay, 0.45 ampere. Now um, third, 3 times of 0.45, 3 times of 0.45 will pass through here because resistor, and 2 times of current will pass through here. Resistance is three times greater. For each resistor, if I consider 0.45 ampere, here the 3 times resistor, 3 times resistance will increase. So current will be here 2 times, because if resistance increases, current decreases. But at the top side, resistance is 2 times. So current will be 3 times here. So what I can write here, 0.45 into 3. 0.45 into 3 is 1.35 ampere. 1.35 ampere. The answer is C. 1.35. The answer is C. 36. See, I just calculated this just in an easy way. Total 5 resistance. So where resistance is greater, current will be less. So yeah, at the bottom side, 3 resistance are there. So if I consider all these 5 resistance, then um, twice into the 3 times resistance is here. So current will be twice. Okay, but here 2 resistance, so current will be more. So 1.35. 37. A battery of electromagnetic force 6 volt negligible inter resistance is connected in the series, and the resistance of resistor 6 ohm and variable resistor of resistance 0 to 4 ohm. Okay, 0 to 4 ohm. The resistance of the variable resistor is changed. What is the range of the voltmeter? Suppose if this is 0, if there is no resistance, there will be no voltage. So R0 equals to 0 volt. Resistance 0 means 0 volt. Now if it is 4 ohm, I can use the potential divider equation C, where we need to find the voltage. That resistance will be at top, means up 4. divided by total resistance of the circuit. What is the total resistance of circuit here? 6 plus 4 equals to 10 into input voltage. Input voltage is 6 equals to, I am getting here 2.4 volt. So the range is from 0 to 2.4 volt. 0 to 2.4 volt. Yes, the answer is A. 37, answer is A. 38. In alpha particle scattering experiment, a beam of alpha particle is aimed at a thin gold foil. Most of the alpha particle goes straight through, are deflected by a small angle. A very small portion of the deflected by the more than 90 degree, effectively rebounding towards the source of alpha particle. Which conclusion about the structure of atom cannot be drawn from this experiment alone? Okay. What is not explained in this experiment? They are asking about this. Most of the atom is empty space. Yes, that this is the conclusion of the alpha scattering experiment. Almost all the space of an atom is empty. The heavy denser nucleus exists inside the atom, and the nucleus is positively charged. So these 3 points they discussed in this alpha scattering experiment. Most of the mass of the atom is concentrated in the nucleus. Yes, because the heavy denser nucleus exists inside the atom. The nucleus contains both proton and neutron. See, no. In these 3 observations, there is in anywhere they are not asking about or gave the information about electron, proton, neutron. No, they only gave the information about the nucleus. Okay, so which cannot be drawn. Yes, I think this is the answer. 38, answer C. The nucleus is charged. Yes, the nucleus is positively charged because almost 1% bounce back to the source. Alpha particle is positively charged. So nucleus supposed to be positively charged because there is a action of repulsive force from the nucleus. So nucleus is positively charged. 38, answer C. 39. A type of of beta decay, an up quark changes flavor to the down quark. Which row shows the new hadron? See, we have 2 types of beta decay. One is the beta minus decay. There, the beta minus decay is also called the neutron decay. So neutron is converted to proton plus 1 electron minus. So neutron means up, down, down, converted to up, up, down. See, here down quark is converting to up quark. So they are asking up quark is down quark. So this is not beta minus decay. It's supposed to be beta plus decay. In beta plus decay, this is called proton decay. So here proton is converting to neutron plus positron E plus. So proton means up, up, down is converting up, down, down plus positron. So here up quark is converting to down quark. Yes, up quark changes flavor to down quark. So this is beta plus. So and this is called proton is up, up, down. So beta plus decay. Which row? New hadron created. See here neutron is created. So neutron is created. And the sign of charge emitted beta particle, definitely it's plus. So the answer is A. 39, answer A. 40. Uranium 238 decay into radium 88 226 after the sequence of alpha decay and beta minus decay. Which row gives the correct number of alpha decay and beta decay? See, we will calculate here. Suppose this is uranium 238 divided by 92 here it is, maybe it's producing A by emitting alpha decay. Alpha is emitting, so it's becoming 90 and 234. Again another alpha decay, suppose it's becoming B, so it is 90 to 88 to 30. We are a bit back. Suppose here it's C. Again there is a alpha decay 86, and here 230. 26 to its see alpha decay to 26 we got that. Now we need to increase the atomic number. How we need to, now we can start it from here. Suppose its M is forming, and there is a emission of beta decay, atomic number plus 1, beta minus decay, atomic number plus 1. 86 is becoming 87, and again it is 226, and then again 80, and yes, we are getting the radium now. Again, if there is a beta minus decay, it's becoming 88 and 226. So we got 1 2 3 alpha and 2 beta. 3 alpha and 2 beta. Yes, the answer is, I think the answer is B. End of the question. Thank you. Thank you all. Bye bye. Be confident. Be confident always. Try to solve. Best of luck for all the candidates. Bye bye.